Here we are at Blake Machine out here in Phoenix, Arizona. Brian's gonna take us on a private tour of his shop. We're gonna head in here and we're gonna see what it's all about. All right, so I'm here with Brian Blake from Blake Machine, and he's been kind enough to give us a kind of a back scenes tour. And we're here because of obviously the F-Class Nationals. I don't come to Phoenix very often, but I couldn't come to Phoenix and not try to get into this place because, as you know, I use a lot of his products. We have the AutoDOD at home. We've got his die for inline seating. And we even get a sneak peek at this is the Paragon, right?
That's correct, the Paragon Action that we designed just specifically for F-Open.
All right, and these are getting ready to ship. Is this some of the first batch right here?
This is some of the first batch. It's actually going to some more beta testers. We've got 7 of them out right now. There's, I think, 6 being shot at the F-Class Nationals. And these ones are going to some other testing, and then we're doing the big run of about 75 of them currently.
Wow. And he was showing me earlier, this is the first stage, kind of?
Yeah, this is first the stock. You know, it's this diameter. That's raw stock here, round bar. This is 17.4, 2¼ inch diameter. You can see that's still a solid face. They get a 3/8 hole gun drilled through it off center. As you can see, it's off center because between the lug and the pick rail on the final product.
Okay.
Then it goes into a 4-axis mill, which goes on that big chuck there and in that center. And then it's just round stock, and then it mills everything and completely finishes the bottom of the action.
And this is one of the things I know you had talked about that was really kind of unique, is that you make it so that if somebody's converting over, this fits almost every custom action out there already, right?
Yeah, everyone we can find and measure dimensions off of. You know, there's Borden and BRL XD, which is the same as the Remington Long 700. You've got BAT B, which is the same as MB 3L, 3LL. You've got Pandas, BAT M. So one of these is Panda. I think that one's BAT M.
Okay.
So most of the common actions that you have out there that you already have a stock for and is fitted and pillared, you don't have to move the pillars. Just mill or grind out your bedding, make sure your height is centered where you want it, and rebed it.
And so most gunsmiths at that point can simply take your stock, grind it out, rebed it. Yep. Your pillars are good to go. Because really that's where your stock's going to kind of lose some integrity, is you have to re-pillar bed it, right?
Re-pillar it, and if it's got finish work or clear work done on it, now you don't have to re-clear it. You know, the handles, we put the bolt handle and the ports in the same places as bats, so that, you know, bats seem to be the majority of what's out there. If they want to try this in something that was stocked for bat already, you can do that.
Okay. And then you were showing me the EDM process. So after the machining...
After this machining, then it goes into a 5-axis mill.
Okay.
That jigs and fixtures and dowel pins here, and then they come out of the mill like this. So this is off the 4-axis. It does the roughing and the finishing of the bottom.
Okay.
And this is after the 5-axis, where it gets serial numbered, ports put in, full tenon put in. Then this has all the machine work done to it. Now it just gets wire EDM'd and sinker EDM'd, and then after that, this is what it looks like coming out of the wire. As
and
you
so
can see,
the difference is we still have metal in here. This is wide open. So if we look down the middle here, so this still has just that rifle bore. This has the actual lugs, everything.
Yep, and the headspace, dimensions, everything's all done.
Okay. And you're doing an integrated rail with it?
Integrated 20 MOA rail that's built on correct 1913 mil spec, which is 10 millimeter spacing.
Okay.
Yep, everything's integral.
That's very cool.
38 stick integral lug.
Now look at this. Woo! That's pretty awesome. I'm assuming like you got people ordering consecutive serial numbers, stuff like that.
We have that, as well as we're trying to stock these as well.
Okay.
You know, I think a big turnoff for a lot of guys even getting into F-Class is it takes a year and a half to get components, to get a build done, and it turns a lot of guys off because they could buy and build a PRS gun on the weekend.
Yeah.
So if we can say, hey, we've got the actions ready, we've got barreled actions ready, you know, if you want to shoot something we're chambering for, and you know, we're working with stock manufacturers to have fully inletted stocks. So a guy could literally have every component, no machine work needed, and just do bedding and finishing work.
That's cool. So I want to go show everybody this wire EDM. Now, I'm not a machinist. I think everybody that watches my channel fully understands that, but I can appreciate how cool this thing is. And I've watched videos of wire EDM, and this is doing that process right now where it's cutting out the lugs, the bolt chamber, everything like that. But I mean, this is pretty
Yeah, you
awesome.
see that? Yeah, that's the profile there.
So there, let's see here. So there's the profile. Okay.
Yep.
And this, you said, it actually does this in how many passes?
4 passes.
4
Does
passes.
a rough cut to get the slug out, and then 3 finish passes. And we're holding a number 8 finish on the RMS scale, and on size less than 2/10 of a thousandth variation throughout the entire thing.
Wow. And then one last thing you were showing me. So we've seen, if you've watched any of the videos, you've seen that Brian's put out. There's different bolt handles, and that's because it's threaded. So I've seen, this is kind of the standard one,
That's
right?
the standard one, and then we have, you know, the threaded versions that, you know, we have a hex machined on here, and then obviously the billet thread there, and then this comes out, and then you can thread that.
Okay.
All kinds of different handles, different shapes, whatever.
Yeah, you had a black one over here that was all done, right? So we've got the handle there.
Anything, yeah, any shape you want, you know, goes there, and spin that off with the hex, spin the new one on, whatever you need.
All right. All right. Well, we're going to head over and see where the AutoDods are made. So here we go. Here we are. We are in the AutoDod production area, and you know, this is probably my new favorite tool that I have at home. And you know, without a doubt, it has definitely brought my numbers down on target. In fact, Brian and I were talking when I got here, and it's going to be in one of my other videos. But I have my new Garmin chronograph, and I actually shot 49 shots with an SD of like 6.1. You know, and that's the kind of thing you see with people that are turning necks, right, Brian?
Yeah, that, I mean, you can run a no-turn system. I mean, lots of guys have had success, but in my opinion, to have success over a 3-day ag, like you're doing at a national event, you have to eliminate that variable out of there with different thickness necks and neck tension on that bullet.
Yeah, and you know, we've talked about this with other people, and I've had conversations with, you know, some other, you know, world-class shooters, and it's all a thing of like margins, right? Like it's what do you call it, tolerance stacking?
Yeah.
Right. So if you don't know your neck thickness, sure, from one lot to another is going to be different, and then suddenly it's, you know, from 1 to 3 lots is different and stuff like that. And I'm as guilty as anybody. I shot no turn 284 forever, and said, well, that was good enough. And it wasn't until I went to the PRCW, you know, the 657, and that I went, okay, I got to do something with these necks, because it needs a little extra help. Yeah. So now these are hand assembled. There's no assembly line. Like this is somebody who is trained to put this together. They're all hand assembled. I know mine's got some like sign offs assembled by.
Yeah, there's multiple checklists, pages and pages of checklists and quality control that even the builder does, and then it goes to a whole separate person to do the final QC checks, and they go over every screw on it, boring bars, everything.
And now that you have, so obviously I've got the AutoDod. I can't even imagine having just the regular one, to be honest. But percentage-wise, I mean, are you still selling like the standard IDOD to the AutoDod?
75% auto.
Yeah.
Yeah, there's still guys that, I mean, they can't afford that extra $800, and that's fine.
Yeah.
And you can get the same precision. It's just you got to have more of a field control rather than having a stepper motor that's doing it all for you.
Yeah. No, that totally makes sense.
And it's all upgradable. So if a guy buys an IDOD and a year later he's like, you know, I got extra funds, I want to buy an AutoDod for, I think it's like $800. We send you everything. All the provisions are already on the plates. You screw it on, you're done.
Oh, really? So I mean, you can upgrade it at home. Yes. No need to send it in.
Correct.
That's awesome. And one of the things we were talking, a lot of people don't know. So if you're out there and you have an AutoDod or an IDOD, you may not know this. And let me see, there's none in here with a center boring bar, is there? But for those that don't have one, so there's your inside cutter. And I bet you didn't know that inside cutter is actually also a case trimmer. And I'm going to be doing a separate video soon showing you how the IDOD and AutoDod are actually case trimmer, and it chamfers, deburrs at the same time as well, right?
Correct, yep.
So you can actually eliminate one of your, oh, here we go, Brian's got one. So you can actually eliminate a tool in your shop, and it's hard to see in the video, but right here, there's a little notch on the end of this, and this is technically like a boring bar, right?
Yep.
And that little notch, now you have that specifically ground into these, and that is a full trimmer, chamfer, and deburr. And it's fairly inexpensive. I'd probably recommend buying an extra head for it, which is just going to be replacing this.
Yep.
You get it with just that inside cutter, and now you can turn your IDOD AutoDod into a case trimmer and save yourself a machine. And for me, that's great. Like, I don't have a lot of space. I really love my trimmer, but if I can free up some space and some funds,
and justify the cost of
you're right,
the whole machine.
You know, like I've always said, and Brian doesn't shy away, this is not a cheap piece of machinery. It is. You know, it's a lathe. It's a custom, handcrafted machine it does come with a little bit of cost, but I also know, and I don't know if Brian's going to talk about this, but you've got some more surprises coming for the IDOD AUTODOD, right?
Yep.
Any that you want to talk about?
Yeah, we've got a bullet pointing trimming system that basically the bullet is capsulated here on the carriage, and then the trimmer head is in the spindle. And with the AUTODOD feature, it comes up and puts the same exact point on every bullet, and is datomed off the back of the bullet. So then your BC will be consistent because you're datuming overall length off of the bullet, where now everybody's pointing where we have to measure that length and then set our pointing dies to that. So now everything's to be done simultaneous, as well as we have a auto feeder system that's we're working on, that's coming out to where basically you have a hopper like a Dillon hopper. They go into this rack system and automatically feeds and knocks the cases out and just sits there and
that runs. To me, that's the biggest game changer, because you know, I know, you know, I'm very much on the automation, right?
Yeah.
And
you can see here we've got a
here we go
set up with the bullet trimming apparatus.
Oh, that's cool. See, look at
we've
that.
We've got a cutter head here.
Okay.
So that spins there.
Yeah.
And then this comes forward here. You can see the touch sensor gets moved to here, so it datoms off of here because that's the constant.
Okay.
It comes there, touches, puts the same point, retracts back. You take this up, you take your bullet out, and it will have the same point on every single one. The BC will be constant.
Wow, that's pretty crazy. So in the next, what, maybe 6 to 12 months, there'll be an auto feeder, a bullet pointing trimmer.
Yep.
You already have a case trimmer. So I mean, this really becomes kind of a multi-tool at that point.
Yeah, and that's what we always want to do when we designed it, and that's why the base plate may be a little bigger than it needs to be, so we can add those features later on. Like when I first did this, there was no AUTODOD, it was just an IDOD, but I had that in mind that, hey, we're going to make this CNC controlled, and hey, we need to make a modular top so that we can put bullet pointing systems in here and trimming systems or whatever we want to do, like you said, modular, so we can have the case trimming system that datoms off the shoulder.
Yeah, that's really cool. Anything else about the AUTODOD that we should know?
That's that one shows the case ejector there, which
this is pretty new, right?
Yep.
Yeah.
That one, and it's all automatic. Has a manual version also, but comes out, knocks the case out. I mean, that's going to be a needed feature on the auto feeder version, because basically the tray pivots up, pushes the case in, and then actually will pivot out of the way, knock that case out into another basket per se, and it comes back down and uses an air piston and pushes the next one in and keeps running and running.
Yeah, I can't wait for that. Like I'm an automation guy. I've got my auto drive. I can decap. I can do all my sizing. I've got my amp with the feeder.
Yep.
So like this is the last piece that's missing, where I can go in and make lunch while I'm while I'm doing everything.
Yep. And my end goal is actually to try and make a 6-headed version to make for these custom brass manufacturers, ADG and stuff, so they can actually offer completely turned precision necks that they're not able to offer now. And maybe really guys that can't afford or don't want to spend the money on this, they can maybe buy extra brass, cost there, and then have better necks right out of the gate.
That's really cool. All right, well, we're going to go check out now. Where are we headed? We're going to head over to...
We can show you some more machining on the actions in this other part of the shop.
And then we'll probably go take a look at the barrels and also where your dies are made. So let's head over there. All right, so Brian was showing us this. This is another one of his machines. It is putting a tenon, the tenon thread, into the face of the Action. And we were just talking, start to finish, how long does it take to do like a full Action with the bolt, everything like that?
About 10 hours with all the supporting
10 hours.
components.
So basically an Action a day is sort of what my mind thinks of, but production-wise, it's not really an Action a day.
No, because we're running multiple machines at a time in multiple steps.
Right. Okay. That's really crazy. This place is huge, by the way. Like, it's amazing all the machines in here. So.
Well, this is 5-axis, so all the features on the Action get put in one setup, one operation.
Okay.
You eliminate stack-up tolerance. Everything's timed. You can see there how it's pretty blinked out.
Oh, look at that.
You hold there, so you can see so far we've just roughed it out. We've got the pick rail roughed out, the sides are roughed out, the tenon is roughed out. Now we're going to come in, it looks like, and it's going to finish the pick rail, and then it's going to bore, actually use a boring bar to bore the threads for the tenon, so they're precision and straight, and then thread mill from there.
So I have to ask, like, you've been machining your whole life. I know your family's been in machining. When you went to do the Actions, I guess, what's your number one most exciting thing about making an Action?
It's something I've always wanted to do for a long time, but being able to fix what I would think maybe some issues that's been in the industry for a while that the end shooter had no control over, you know, fire control system and whatnot, where these action manufacturers, they're not competing. They're building actions for competitors. Well, I compete, so I see all these things that shooters need and they tell me, and now we have a way where we can incorporate all that and hopefully fix those issues that they have.
And what's your, I mean, again, I know it's all relative because it's business, but like when you think about making the Actions, what's your biggest, like what was the biggest reservation when you guys were sat down and said, we're going to do this? What was the biggest like reservation?
Machinery costs. The wire EDM by itself was $180,000.
Big investment.
Big investment. This machine here, another $160,000. So you're talking spending $500,000 just on a couple machines. But we didn't want to buy old, wore out, used equipment or substandard equipment where we produce substandard actions. If we're going to produce the best, we need to use the best machinery, and that's why we went this route.
Yeah. That's a big turret up there.
Yeah.
Look at that. Look at this turret up here. Jeez. All right, let's go take a look at where the barrels are made. He's going to get that thing running. Okay, so we are here. Now, this is the machine that does what? It cuts the grooves in the bore?
Yeah, it creates the rifling.
Creates the rifling.
Cuts the grooves.
So barrel's going to go in here. It's going to get held in place.
Yep.
This little thing controls the
indexing.
And that determines how many grooves it has.
Correct.
And so you only run 6 groove?
That is correct.
6 groove. And then this is the actual cutter. We were talking about this a minute ago. It's just this tiny little thing. I mean, I'll try zooming in, but it's really hard to see. It's this tiny little cutter. And what I found out is, so you cut on the pull stroke, then it gets pushed back through the barrel, but they actually turn this and it lowers the blade so that it doesn't touch the inside.
Yeah, there's actually, comes over here and it pushes that wedge forward, and you can see there, you can see the cutter here going up and down. So as far as I'm aware, we're the only manufacturer that does that, so you don't push the cutter backwards through the groove of the barrel and drag it backwards. So when it comes here, this finger, when this is in the barrel, it actually comes and hits that retractor and then pushes that back. And then when it's pushing it back through the barrel, that cutter is actually below the surface. And then when it comes all the way here, this is down like this, it bumps that taper back up, the cutter comes back up, and it actually bumps this also, and it indexes 1/10 of a thousandth to raise the cutter up and keep cycling through.
And now this machine's been in your family for quite a while, but how old is this machine?
This machine is 120 years old.
120 years old, so 1903.
Yeah. And
wow. But I mean, obviously it's been rebuilt, you were telling me.
We've revamped it, done some updates, re-scraped everything, hardened rods, you know, so that we're able to make precision barrels.
What's the biggest challenge in making barrels?
Oh, that's probably keeping all the defects out of it, keeping the choke out of the barrel, out of the rifling, keeping the ratchet out of the profile of the rifling. You know, we've been gun drilling industrially for 60 years, so we know how to make long straight holes. It's just, you're relying on everything is on that cutter, so if anything goes wrong or a chip gets stuck in somewhere, then that barrel basically gets scrapped.
Wow. And what's the number one thing, like I'm assuming obviously you sell a lot of barrels come back to you. What's the number one thing that if somebody sends it back, you find, I don't want to call it user error, but what's probably the most misunderstood thing about a barrel that maybe customers aren't quite as educated on?
The first thing that gets blamed is the barrel. It doesn't matter what it is, right? We've all seen it at matches. My barrel's shot out. My this, my that. Next thing is the scope. It's the two things that the user doesn't have control of, so it's the first thing they blame.
Yeah.
I would say, you know, it doesn't happen very often, maybe 1 or 2 barrels a year.
Yeah.
First thing I do is I get it back, I inspect it. If I didn't chamber it, I'll actually put it in my lathe, dial everything in, and check chamber concentricity, check freebore diameter, things like that. After that, if everything still measures good, I'll screw it on a gun and I'll take it to 1,000 yards and shoot it.
Oh.
And I will shoot everyone that, you know, and I don't want to say prove wrong, you know, the end user, but show them, hey, it's not the barrel, let's look elsewhere. Let's look at your scope rings or your scope base or your bedding. And then usually I'm able to help them find what the actual problem was.
That's really cool. That's really cool. Okay, well, we're going to go look at where the dies are made now. before we get to the dies, Brian stopped me. I've never seen this before. I think we've all heard of hand-lapped barrels. It's a source of pride for a lot of companies. But Blake's barrels are really unique because they are the only ones that are CNC lapped.
And this is honing. This machine is honing.
So this is honing. The one behind me is lapping.
So this is prior to rifling, and this is lapping. This is post rifling.
Okay.
As you can see here, we're able to. This is a carbon fiber rod. We're able to pull and push coaxially straight on that barrel, so we don't get bell mouth ends on the barrel. We're able to monitor the forces throughout to make sure there's no tight spot in that barrel.
Okay.
So everything is seat controlled. So when you hand lap, you're having to accelerate and decelerate, and you're not pulling and pushing dead straight. So you may get that bell mouth on the end. Maybe the rifling is a little bit bigger on the bottom because you're pushing down when you're pushing in. There's a lot of variables to the human there. So we try to eliminate that by CNC lapping. It creates everything straighter. We monitor the forces, make sure everything's linear throughout. There's not a tight spot.
So help me understand, because I'll admit this is an area I'm pretty deficient in. Obviously, I know what lapping is, but what's the importance of lapping? How do you know if you've lapped enough or overlapped, or like what is it that makes lapping such a point of pride for so many barrel manufacturers?
So in the beginning, for years, it's been to take out imperfections. Since we hone our bores prior, we don't have tooling reaming marks. So most manufacturers are using the lapping to take out the reamer marks. That's what's on the lands or the through bore.
Okay.
But since we honed prior, we don't have that. What we're trying to do here is just get everything in that barrel to be going the same direction as the rifling. What that does is eliminates copper buildup, carbon buildup throughout.
Okay.
So we CNC lap there, and they're CNC honed before they're rifled.
Okay.
And we've had to build these machines, obviously, to do all this.
And the honing just means that you're basically polishing the bore?
It's cutting it.
Or
so
cutting
it uses a stone. See if I can find an old stone to show you here. That's the stone.
Oh, wow.
That's an actual honing stone, and that has a predefined grit on it.
Yeah, you can barely feel that.
A certain finish, and it has a tapered wedge, and we're able to bring that up, and we hone that entire bore after reaming to be at a surface finish of about 16.
Wow. Wow.
So after reaming, they get honed.
Huh. All right, on to the dies. So he doesn't have any of the machines running today, but he's going to show me kind of his backstock of the dies and stuff. So what do we have in here?
So we make all of our dies from billet ourselves. We don't start out with pre-made blanks.
Okay.
And it's all made on bar feeder lathes, so everything's done in one operation.
Okay.
Single point cut. They get salt bath nitrided after for the sizing dice, and we offer them in different neck diameters. These are reamers that we...
Yeah, these are all your FCP reamers?
FCP reamers we sell. You know, Manson JGS.
No turn, Manson.
You know, we sell the support equipment, obviously, where we have Girard trimmer bodies.
Oh, yeah, because you do the whole package. I know Eric's talked about that. And, I mean, it's really interesting. So, I mean, it shows your commitment to the sport that, you know, you're not out to alienate people. I mean, look, he sells a no-turn chamber. So, you know, you can do whatever you want.
Yep. So, yeah, we build all of our own decapping assemblies, our seating stems, which seat right off the ogive of the bullet rather than the tip of the bullet.
And those are specifically for the 180 hybrids?
That is correct.
Are you going to expand to like 184s? Or?
So 184, it actually has so much of a similar nose in that portion. They work for that.
Oh, it does?
The 195s, yep.
Okay.
So the 30 cals and the 7 mils we've done, we get a lot of people wanting us to do 6.5s and 6s and 22s, so we're going to venture into there next.
And we've always got go-no-goes?
Go-no-goes, headspace gauges, and then we've got sizing or seating dies, components here.
Yeah, I know.
Yep,
I recognize these.
Yep, that's what they come.
Yeah, we've got all the...
when they're fully assembled. Bore guides.
Yeah, now this is really cool. I have one of these, and I haven't really shown it off too much in a video yet, but what's really cool about this is this fits just about every action, right?
That is correct.
And you move the rubber bands around, or you know, the O-rings around here to help it kind of stay snug depending on the length of the action holes, or the length of the action, you know, where it fits in the ports. You know, like mine, it was a little snug. I took off 2 of the bands.
Yep.
You know, it gives you a chance to kind of move it around however you want, but I really like it. The only thing, I've shown it to a couple of people, they really want a solvent port.
Yeah, you know, and we're going to offer that now where half the guys want it, half the guys don't. So
I don't use it. Like
I don't, but other guys do. So yeah,
Yeah.
we're just going to mill a port in there for guys.
Yeah, I'm not a solvent port guy, but
So yeah, that's kind of the dies that we sell. We do them for different specific calibers as well. That's all made on our lathe and mills.
okay, that's really cool. Well, hey, Brian, I appreciate you taking the time out. I know, obviously,
Sure.
you know, you're in the thick of the competition just like I am. It's not easy to take time out of your day to do this, but I really appreciate it. Thanks for having us in the shop here, and we'll see you out on the line at the 1,000 tomorrow.
Thank you, John.
All right, thanks, Brian.